All right, so today we're going to pick up with Chapter 3, Section 4. And the first thing we want to do is a couple of warm-up exercises. And so what I want you to do right now is pull out your notebook. I'm going to pause the video. Actually, you guys are going to pause the video. Pause the video now, pull out your notebooks, and write these down. Now, once you've written them down, I'm actually going to pause. I'm going to do the work, and then I want you to check your work. Okay, checking your answers. I've worked out the 6 examples here. There's a couple of things I want to point out. Notice when it says solve, at that point, what you should be doing is making sure that you are setting x equals. So I'm talking about examples 1 and 2. So they should be solved. Expand should look bigger. Remember, we're using log properties, so division is really subtraction. Multiplication is really addition. And powers are really coefficients. Okay? And so the last 2 examples, they condense, and then we're going to make them look smaller. Okay? So you can pause now if you need to, double check your work, and then we're going to head over to today's assignment. Okay, I actually worked those. Okay, so for today, what we're going to be doing is solving exponential and logarithmic equations. And what I want you to be able to do when we're done, and this is just day 1, is we're going to take exponential equations and we are going to convert them into regular equations so that we can actually solve them. So I'm going to ask you again now, pause the video, write these down, and then I'll show you the solutions. So write these 4 equations down. And I'm going to tell you to pause. I seriously need you to pause the video. Okay, so pause it now. Okay, so the first 2 examples are going to be when the bases are the same. And so this becomes our rule. If the bases are the same, then the exponents have to be the same. This would be as simple a problem as you would see. Okay, so if the bases are the same, then the exponents are the same. Okay, the next 2 examples, the bases are not the same. And so what we need to do is we need to make the bases be the same. And so I'm looking to make 2 out of 32. So that's 2 to the 5th. So once I have my bases the same, I can now solve for x. Same here. I'm going to start by rewriting the problem. And 4 and 8 cannot be a single base to the same power. However, 4 is really 2 squared, and 8 is really 2 cubed. Now, in Algebra 1, we learned a rule that said when you are raising a power to a power, you want to multiply those. So this becomes 2 to the 6x is equal to 2 to the 3x plus 1. Notice my parentheses, because that's going to become extremely important for you. And so now, the bases are the same. We can say their exponents are the same. Notice I'm showing every step. If you don't need to see every step, solve for the variable alone by itself on one side. I get 3x equals 3. Divide both sides by 3. I'm going to get x equals 1. Okay? So now when we do this, I'm going to scroll back up. The first thing we need to do is we need to make sure that the bases are the same. Once the bases are the same, we can say that the exponents are the same. All right? So those would be the first few problems. Next examples. Okay, so we're going to have you pause it here. You're going to be solving. What I want you to do is write down these 4 equations, and then we're going to solve. Write them down, please, now. Okay, now that you've written them down, I want to go ahead and we're going to do the same thing, only now I can't make the bases be the same. So I've got to convert them using log properties. So I'm going to do the first 2, and then I'm going to have you pause and do the next 2. So the first thing we want to do is, remember, our log property that says that the log of some base, that's our rule. And so we can make this say b to the y power is equal to x. So we're going to put these items back in their original places. So the 21 goes here. Sorry, I just hit the mic. Log base 6 is equal to 2 to the x. Okay, that's really what we're doing. Now what we're going to do is we're going to use the change of base formula. And now we're just going to take this and we're going to divide this quantity. And we're going to divide it by 2. Notice my orders of operations, okay? So we're going to leave this example here, and I'm going to walk through one more before I allow you to do it, okay? So notice I take the 101 and I put it here. I'm then going to take the exponent and I'm going to put it here. This becomes the log base that I'm looking for, okay? So notice the pattern. And now we're going to use change of base formula. Notice on day 1, I'm not here today. Remember, you're watching this with a sub. I'm not having you use the calculator right now. We're going to do the calculator button pushing when I'm done. So these would be what we would call exact answers. So now I'm going to take this quantity and I'm now going to subtract 4 from it. So I have x equals the log of 101 over the log of 3 minus 4. This is my final answer, and that's what I want you to write down in your papers, okay? So what I want you to do now is I want you to pause, and I want you to try examples C and D on your own, okay? So right now, on your papers, you're practicing examples C and D. Go. Okay, so here's example C and D worked out. Notice step 1, all I'm doing is rearranging it into exponential form. I'm now using the change of base formula, and now I'm using algebra 1. Example D, on the other hand, is a little more difficult because in order to use log properties, I have to make it look like this first. Okay, so this minus 4 plus 4 thing here, that has to be our first step. Okay, so now I have it in the proper form. Remember, look at where everything is being placed. Okay, same pattern. I use the change of base formula. I move over the minus 3, and then I algebra 1 it to get to my final answer. Okay, so those are 4 more examples. At this point, if you need to pause, please pause now and record the rest of the work. If you don't need to pause, we're going to go ahead and look at the next 6 examples. And then we will be done. Okay, so there's actually 6 examples here. I'm going to go ahead and have you copy down these 4 first. So please pause now and record these 4. Pause, record, because I'm going to scroll down, and then I'm going to have you record the next 2. And there's the last 2 examples. So you should be pausing, first 4, last 2. I want you to pause now and record the last 2 examples. Okay, I want to work through these examples while I'm talking to you because these would be the level 3 for exponentials. So we're going to use some algebra 1 to solve for the variable first. So we're going to get 2 to the x is equal to 14. I'm hoping I didn't make any math errors. Now we're going to use the circle of life. We're going to put the 14, the 2, and the x, and we're going to use the change of base formula to get our final answer. Okay, remember, today we're just doing the arithmetic. Tomorrow we'll punch the buttons on the computer or the calculator. Okay, so what I want to do now is remember that this When I see e, that's really the natural log. So I want a natural log both sides. Now this is really what we're doing, by the way. Only with e, it makes it look really nice. And remember now, I can use my rule for powers. So I get x. And remember, natural log is equal to log base e. So log base e of e is what I'm looking at here, okay? So log base e of e is just 1, and that's equal to the natural log of 72. So x is equal to the natural log of 72, okay? Now, I could also have done this using log base e of 72 is equal to x. So the log of 72 over the log of e is equal to x. Both of these are exactly the same, and on the calculator you will see that when we punch buttons tomorrow. Okay, the next two examples. I'm going to do it again. I'm going to natural log both sides. This comes down. Remember that the thinking bubble here, thinking bubble, natural log of e is equal to 1. So this side becomes x is equal to the natural log of 13. On the other option, I could say log, and I'm just rewriting e 13 equals x, and I could say log of 13 over log of e is equal to x. And either of those options would be absolutely correct. Now, if the bases are the same, then the exponents are the same. Now, I'm going to put a star here because we're going to talk more about D tomorrow, because this one requires that we do a little bit of math in terms of eliminating options. So I'm going to factor. Thank you, Algebra 1 teachers. I get -2 and -3. Now I have two answers. And so what I really have to do is I have to come back up here and I have to check both of my answers. And so when I check both of my answers in my thinking bubble, I'm checking my answers, and I would get e to the -9 when I plug in 3. Now when I plug in -3, I get -15, I get -9. So this -3 works out. When I plug in -2, I get e to the -4 is equal to e to the -4, and that one checks out as well. So we are good. We've checked both answers. Okay, the last two examples. I'm following along. If you need to, you can pause at any time and take a look at the work. So the first four examples, if you need to pause, pause now and copy those down. Pause or moving on. Okay, the next two examples. In order to use my rules, I have to have it in the proper form. So I get 4e to the 2x is equal to 5. Divide both sides by 4. I get e to the 2x equals 5/4. Now with e, I like to do what I call log it. So I want a natural log both sides. I should write it. Natural log of e to the 2x is equal to the natural log of 5/4, which means this side becomes just 2x is equal to the natural log of 5/4. And now I just want to divide both sides by 2. And so I get x is equal to the natural log of 5/4 divided by 2. Now remember, I'm walking you through this right now so you have examples in front of you. Okay? So go ahead and copy that work down if you need to. Pause now, or moving on to the next example. And so we have the same issue here. So we're going to move the 3 over, and I'm going to move the 2 over. So I get 3 is equal to 3e to the x. Divide both sides by 3. I get 1 is equal to e to the x. Hey, without doing any real math, anything to the what power is equal to 1? Anything. In the whole world, 1 billion to this power is equal to 1. 10 to this power is equal to 1. 5 to this power is equal to 1. I'm hoping you're all yelling at me right now, Miss Collins, the answer is 0. And it is. But let me show you. I'm going to log both sides. And on this one, I do want you to use your calculator. And I want you to see what the natural log of 1 is. And I want you to see that that answer is, in fact, 0. Okay? So you can pause now and record this onto your paper. Pause now, and I'm moving on. Okay, so how do we get the variable out of the exponents? You have two choices right now. We can use what we call circle of life, okay? And that would be like the second set of examples. You have the first option, which is where the bases are the same. Or you have the last option where you can log both sides. And we use log properties for this. And it works with anything including log base E, natural log. But log both sides, and we are going to use our log properties to do that. Okay, log properties. So here's what I'm going to have you do. I'm going to flip to the next page, and you're going to copy down this classwork assignment. And then I'm going to pause here because I want you to write this down. Okay, so you've written this down. And now here's your assignment. It's actually classwork, not homework. My bad. This is class work. Okay, you're working on this in class. I expect you to have it done when I come back tomorrow. Okay, please, please, please work well and quietly on this. Miss Clark and your chatty Cathys, please keep it down. And Mr. Jafarov, if I come back tomorrow and you do not have your notes taken, I am going to be very upset with you. All right, the rest of you, get to work, and I will see you on Tuesday.